Hey guys, so this is our next short little unit. It's really just like 2 to 3 days. It's a very specific type of word problem. So start off by pausing the video and do the do now. This is the linearization that we talked about yesterday. So it is a calculator active problem. So they gave us 0. So we need to plug in. Helps if I put the pen on. Alright, so I got 0, comma, and then I need to plug in. So the square root of 4 plus sine of 0 is 2. So our point is 0, 2. And then we need to find our slope. Y prime is square root of a root, 2 root, 4 plus sine x. Derive the inside, cosine x. Plug in 0. Cosine of 0 is 1 over 2 times the square root of 4, so we get 1/4. So y equals my y value 2 plus 1/4 x minus 0. 2 plus 1/4. We're plugging in 0.12. This one actually you don't even need a calculator for. Plus 0.03, so 2.03. B. All right, so accumulation. So this is accumulation. Think of this as like the basic of velocity. If you have a function and it's a rate, what's the meaning of it? So remember when we did velocity, when we integrate velocity over time from A to B, it's displacement. Right? We've talked about that. So the integral of a rate is just the change in the amount. Right? So if I integrate, say, the rate of water being poured, right? Water poured. That would be the change in the amount of water. So it's just taking that rate and turning it into like a total amount, but it's really about displacement. So if V of t is the rate of production of Miss Fazone action figures per hour, what would the integral of V of t be? So that would be the number of Miss Fazone action figures produced in one day over those 24 hours. And that's it. And then the last thing, really common, you're going to see this a lot, where one of the rates is the amount you're taking off. Well, that's not very good. How do I? Oh, okay, there we go. There we go. So the rate that I plow snow off my driveway versus the amount of snow falling. So we'll see this. It's like that, the whole idea of in versus out. So we're going to spend a lot of the problems do handle that. So it's going to be in minus out, right? The total that's going in minus the total that's coming out. And these are always rates. Like pretty much all of them are going to be rates. So write an equation to represent the amount of snow on my driveway. So the amount of snow, let's call that D for driveway. D of t equals, so these are rates and I want a total amount, represent the amount. So that's my in, snowfall, S of t, minus the out, P of t. Now, there is an issue. I can't have a t here and t's here. So we need to make this from 0 to t hours. And I'm going to erase this. And I'm going to make those any other letter. So I'm going to make them x's. Okay. dx. So the amount of snow on my driveway at any time at some time t is the integral of s of x minus p of x. The total rate falling versus the total rate I've plowed off. And then sometimes you're going to have initial, right? So if I started, when I started plowing my driveway, there was 2 inches. So then you can sometimes have that initial in there. So initial plus, okay? So let's look at our first AP problem. This is about as basic as we can get. This is one of the few that is a no calculator, right? Most of these will be calculator. I'm actually going to make a second video to show you how to use the calculator for this. So read the problem carefully. When I did this earlier, I did not read it carefully and missed some of it. Water is pumped into an underground tank at a constant rate of 8. So that's our in, right? Right there, that is my in. And then water leaks out, so that's our out, at a rate of the square root of t plus 1. So that's our out. From 0 to 120 minutes, at time t equals 0, the tank contains 30 gallons of water. So what does that 30 represent? That's our initial. So notice, again, we have an in, we have an out, and we have our initial. How many gallons of water leak out of the tank from 0 to 3? Well, out is this, but that's a rate. We want a total amount. How many gallons? That means we're integrating. So the integral of t plus 1 dt from 0 to 3. Now, do we need the initial amount? No, all they want to know is how much is going to come out. So this is a no calculator, so we need to be able to do this. T plus 1, that's really 1/2. 3 over 2, 2/3 from 0 to 3. Plug in 2/3. So this is the square root of 4 to the 3rd. Square root of 4 is 2 to the 3rd is 8 minus 1. So we end up getting 14 over 3 and gallons, right? And we're done. All right, B. How many gallons of water are in the tank at t equals 3 minutes? All right, so we just figured out how many gallons leaked out. So again, it's going to be this whole initial plus in minus the out. We just figured out the out right there. Okay. So our initial amount was our 30 plus the in. What's the in here? The in is 8 gallons per minute, so 8 per minute times 3 minutes minus our 14 over 3. So we get 54 minus 14/3. And on the AP test, you can just leave it like that. It's not a calculator problem. You don't want to mess it up accidentally. You can go through and figure out the answer. I think it's 48, 49, 48/3 or something like that. I can't remember. All right, C. Write an expression, A of t, for the total number of gallons in the tank at time t equals 0. So we literally just did that in this last problem, right? We're just going to take this and turn it into an integral. So A of t equals our initial. The initial was the 30 plus the in. So now we can do this a couple ways. I think the easier way to do it is just to do AT. Our in is 8 gallons per minute, right? 8 per minute. Plus, whoopsies, just kidding. So that's our in, and then minus the out. The integral from 0 to t of the square root x plus 1 dx. And again, we want that to be, put some x's in there. All right, and the last one, d. This is the hard one. At what time t between 0 and 120 is the amount of water in the tank a maximum? All right, so how do you find a maximum? Always keep that in mind. Go back to your definition. A maximum is where the derivative equals 0. So we need to figure out, where does a prime of t equal 0? So I'm going to rewrite my formula. So we have a of t equals 30 plus 8t minus the square root, the integral from 0 to t, x plus 1 dt. So I'm going to take the derivative. Derivative of 30 is 0, derivative of 8t is 8, so 8 minus the square root, t plus 1. We're setting that equal to 0. So then 8 equals the square root of t plus 1. So we get t equals 63. Remember, though, we also have from 0 to 120. So now the question is that really the biggest? So we know a of 0 is 30. We need to figure out, is a of 63 the max? Or is a of 120 max? So let's think about this. If I'm finding a of 63, that's 30 plus 8 times 63 minus, I keep wanting to put plus, minus the integral from 0 to 63 of the square root of x plus 1 dx. So is that 30 plus, I don't know what 8 times 63 is, minus 2/3 x plus 1 from 0 to 63. Who's going to be bigger, that or a of 120? 30 plus 8 times 120 minus 2/3 x plus 1. Now, I think it's pretty easy to convince ourselves. I forgot our 3/2. We can pretty much convince ourselves that this is going to be smaller because here we're subtracting off. You plug in 120, that's 11 to the third. So you're subtracting 2/3, 11 to the third, versus over here, you're subtracting 2/3, 8 to the third. No, the square root, the square root of 8. 8 to the third versus 11 to the third, this is going to be the max, right? This is your max. It's greater than this. So you can just say a of 63 is greater than a of 120, right? And you can kind of just if you can convince yourself of that, that's good. All right, so that's the AP problem. Now let's look at the answer and how this was graded. That gives you a point. Oh no, what did I do? All right, so A. So this is exactly how we did it. They have this other method. I think this is just using DLDT. Okay, and they actually created the function and solved. So notice for the method, we have our definite integral. We have limits, the integrand, and the answer. So there's 3. The awesome thing is we see this a lot. Just by putting the integral from 0 to 3, that gets you a point. Putting the radical t plus 1 is a point, and then getting the answer is a point. So they really do break this down really nicely. Now for B, they only give you it's only the answer. So as long as you get there, that's all that matters. And then C, just by putting the 30 plus the 8t, or notice here they put the integral, they put the 8 in the integral, you can do that also. So that get you a point, and knowing to subtract that square root got you a point. And then again, they had that other method. And then for the last one, so knowing setting the derivative equal to 0 gives you a point. All right, so they really break this down nicely. Go back. Okay. Solving for t gives you a point, so the 63. And the justification, like that, I think that is the hardest point to get. That was kind of a lot of work, like really convincing. And even though they didn't really say much, I think it's even just convincing yourself that 63 is the maximum and it's not going to be 120. So that's kind of a lot of work for the 1 point, but the rest of this was very doable. All right, next problem. So this is a more common problem. It is a calculator-based problem. I would say 95% of these are calculator-based. So take a minute, pause the video, and read through this problem. So it says the number of gallons P of T of a pollutant. So this is the number of gallons, the total amount, right? Changes at a rate. So this one is our rate. All right, so that's our rate of change, gallons per day, where T is measured in days. There are 50 gallons of pollutant in the lake at time T equals 0. All right, so that's our initial. So let's label that initial. The lake is considered safe when there are 40 gallons or less of pollutants. That's kind of this other thing that kind of differentiates this from some of the other problems. So changes at a rate, and then initial P of T is the total number of gallons of pollutant. All right, so A. Is the amount of pollutant increasing or decreasing at T equals 9? So increasing, decreasing, that's our derivative. So they want to know what's happening with the derivative at 9. So P prime of 9. So I'm going to just plug that into my calculator. Can you do this by hand? Probably. I wouldn't recommend it. I would put that into my Y1 and plug in 9, and you get negative 0.646. So, and then make sure you answer the question. It is not increasing, since P prime of 9 is less than 0. So it is actually decreasing at that point. B. For what value of T will the number of gallons of pollutant be at its minimum? So I'm going to say this so many times. Go back to your definition. What is a minimum? The pollutant is a minimum. To find a minimum, we take our total amount, our P of T, we take the derivative and set it equal to 0. So when does P prime of T equal 0? So 1 minus 3e to the negative 0.2 root T equals 0. So we can do this by hand. If you want to put that into y equals and find the 0, you can. I think this one's actually easier just to go through and do the math kind of, but not 100% by hand, but so I'm going to solve for e equals 1/3. The ln on both sides to get rid of the e. So negative 0.2 root T equals the ln of 1/3. Divide. I'm going to put that in my calculator. So let's see, ln of a third is a negative, because it's between 0 and 1, divided by negative 0.2. So I got the square root of t equals 5.493, which means square both sides. Square the original, not the estimated version, and I got 30.174. All right, let's go back to the answer. Is the lake safe? Sorry, that's for what value of t will the number of gallons of pollutant be a minimum? So then the question is, what's happening on either side? So we can check this in a bunch of ways. We can find the second derivative, and that's actually might be the easiest way. If we use the calculator, find the derivative, p double prime of 30.174. So I'm going to use the calculator, take the derivative of the derivative, x at 30.174, and I get a positive 0.018, which is greater than 0. So since based on the second derivative test, I know that this is a relative min, right? The second derivative, the concavity is positive, right? So that means that 0 is actually, it's going to be a min. All right. Is the lake safe when the number of gallons of pollutant is at its minimum? So that's asking, is the lake safe? So that goes back to our 40, right? We need the amount of pollutant to be less than 40. So how many gallons of pollutant are in it? So if we have, in the last problem, t equals 30.174, we need to find the total amount of pollutant at that time. So if we have the derivative to find a total amount, we're going to integrate. So it's the integral of p prime of t from 0 to 30.174 dt. So again, we're going to use our calculator. I'm making a video on how to do this, so watch that video also. 0 to 30.174 y1, comma x, and I get, it always takes 1,000 years, negative 14.896. Now, is that the answer? Now, I skipped something, so think about what I skipped, if you haven't been yelling at your computer already. The number of gallons of pollutant is at its minimum. Well, t equals 30 was our minimum. What did I ignore? There is one piece of information that I ignored. I mean, that's less than 40, but can you have a negative amount of pollutant? No. Remember, this number represents the change in the pollutant, right? That's the change in the pollutant. We need to add to that our initial value. We started out with 50 gallons of pollutant. So it's 50 plus negative 14.896. So I'm going to add 50 to that. And I get 35.104, which is less than 40. So this is a yes. The lake is safe. Since the total amount of pollutant is less than 40. All right. And finally, D. Oh my gosh. Let's check the answers. T equals 5. Okay. An investigator uses a tangent line approximation for P of t at t equals 0 as a model for the amount of pollutant. At what time does the model predict the lake will become safe? So we need to create a tangent line. So what do we need for a tangent line? We need our slope and we need our point. So they're giving me my t-value is 0. What do we know at 0? At 0, there are 50 gallons. So 0, 50. And then I need my slope at 0. So p prime of 0. Well, that's 1 minus 3e to the 0, which is negative 2. So they want to know, when will the lake be safe? So when will the pollutant be what? At what time will the pollutant be safe? That's that 40 again. So we're going to set our tangent line equal to 40. I never actually wrote my tangent line. Y equals negative 2x plus 50 is my tangent line. We're setting that equal to 40. So 40 equals negative 2x plus 50. Negative 2x equals negative 10. So x equals 5, or t equals 5. So at what time t? At t equals 5, the pollutant hits 40. Is t equals 5, p of t is 40 or less. And that's it. We're done. All right, so let's look at the answers. All right, so here's our answer key. A is only 1. Like, you have to have all of that. If you just put this piece, whoops, I should put a pen on. If you only have that, you're not getting any points. You have to actually say it's less than 0, so it's not increasing. You have to make that statement. Just because you get that it's negative, the AP people don't necessarily know that you understand that that means decreasing. So make sure you make that statement. All right, B sets p prime of t equal to 0. So minimum, derivative equals 0. Solve for t. So those two pieces were like the easy points. And then the justification, they used the first derivative test. I used the second. I used the second because I think it's easier in this case trying to decide what's happening to the right and to the left of 30.174. I mean, you could plug in 10 because you have a calculator. You can plug in 40, see what you get. I just think it's like an awkward, I don't know. I feel like it's awkward to use the first derivative test. But remember, you're not allowed to actually use the number line. You have to say it's negative when you're less than 30.174, positive, which means it's a minimum. All right, letter C. Again, don't forget that initial, right? Initial plus the integral, which is less than 40. So this is nice. The integrand, just putting that on the inside the integral. The limits, 0 to 30. And the conclusion. So the conclusion kind of involves that 50. And then the last one, just finding the slope of negative 2 gives you a point. And then figuring out the t equals 5 gives you a point. All right, I'm going to stop the video here. I want you to do number 2, this one about the amusement park. And, oh shoot, I just showed you the answers. And number 2, a tank contains 125 gallons of heating oil. Please try these 2 problems on your own. Don't look up the answers. I'm gonna put out the video for those 2 answers tomorrow. I really need you to practice and work through them. All right, so do these problems. We will talk about them during our meetup. I will post the video of these answers. If you have any questions, feel free to email me. I will respond. I'm checking my email all day. All right, have a great day, guys.